On behalf of Panimalar Institute of Technology, I welcome you all for the AACTE Pre-Rana Grade Training Program on CSC for the subject Database Management System. And for today's session, we are going to discuss the topic Integrity Constraints. So, integrity constraint is the topic of discussion for today. So, here comes the outline of my presentation. Um, So to proceed with integrity constraints, first we are going to summarize the concepts of relational model. So first we are going to focus on the relational model concepts, followed by we are going to discuss the integrity constraints available in SQL. Okay, so moving on with relational model concept. So the relational model has arisen from the theory of relations. So theory of relations um, provided the foundation for the invention of relational model. In general, relational model is a mathematical concept based on the ideas of sets. So, whereas the relational model was first proposed by Dr. E.F. Code, who belongs to IBM Research Lab. So, while he is working on the project named R programming, that is R managed, that is the project title is named as R. So while working on that project, he come to a conclusion that he found a relational model. Okay, so relational model which is to be used for the large shared data banks. Okay, he addressed the same in communications of ACM by 1970. So EF Code introduced the concept of relational model. So the above paper caused a major revolution in the field of data management system as well. Uh, the Dr. E.F. Code, okay, he is covered with ACM Turing Award for invention of the concept relational model by the year 1970. Okay. So let me discuss the definitions of a relational model. What is a relational model? So the basics are the facts of relational model. So in a relational model, we used to portray the data in the form of table. Okay, so each relation is to be presented as table of volumes. Okay, a relation or we can say a table which consists of rows and columns. So your relation has a set of rows. Okay, and the elements in each row represent certain facts that correspond to a real world entity or relationship. So in the formal model, rows are called as tuples or tuples. And in each column, it has a column header that gives an indication of a meaning of data items in the column. So in the informal model, the column header is called an attribute name. Okay. So in general, we can say that a relation is modulated as a table, whereas a table consists of rows and columns. Rows constitutes the record of, that is the information about a real-time entity. Okay, and the column defines the attributes of the entity. Okay, so here comes the example. So here, to map the student relation. So the name of the relation is student. Okay, and to map or to model a student as a relation. Okay, so we have for a student we have various attributes. Student has various attributes like a name, SSN number, social security number, a telephone number, address, and office phone number, age, and GPA, his score, his or her score. So these are the attributes belongs to the relation student. Okay. So the column, each column represents the attributes of a relation student. Okay. So whereas each tuple holds the information about the particular student. For example, the first tuple holds information about the student named as Benjamin Bayer. Okay. So a relation is represented as form of table. Okay, so the table consists of rows as well columns. Row represents a record of real world entity. Okay, entity belongs to the relation. Okay, and the column represents the attributes of the entity. Okay. Okay. So we come to know what is what is rows, what is for rows, and what is for columns in relation. Okay, and the important fact about relation is so there exists a important element named as key. Okay, key. So key refers. Okay, and key is an attribute, okay, which is used to uniquely identify a row in a relation. Okay, so for example, here consider the previous example. So in the student relation, we have various attributes like name, SSN, home phone number, office phone number, address, age, and GPA. Okay, so here so to retrieve, to uniquely identify a record of information. So to uniquely identify a record of information, okay. So a particular attribute contributes a uniqueness. That is, um, um, in simple term, we can say that attribute which differentiates, okay, which differentiates the records which are stored in relation is known as a key. Okay, so which facilitates a differentiation, which helps us to retrieve a record from your relation in a unique manner. So, like that attribute is named as a key. Okay, so here we have so many attributes like name, SSN. Okay, so in this attribute, among this attribute, so which attribute we can elect as a key attribute? Can we use name as a key attribute? So in real world, different person can assign a same name. So we cannot use, so name can allow duplicates. Okay. And so in home phone, there may be some person who do not have the facility. Okay. And address, can we use address or official phone? Same age can also be found for multiple records and same GPA. Okay, so the unique attribute, so the attribute which has a unique value, okay, must act as a or that determines each record in a unique way. Okay, so the attribute must be a unique attribute. So that is the value of attribute must be unique, not null. Okay, so we can use SSN because SSN, so SSN is like other number in our country. So in America and all, they will call the unique identification number as SSN, Social Security number. So each person will have different SSN. So we can use this particular attribute as a key attribute because this disallows duplicates and null values. So we can use SSN as a key attribute. So key means, so key allows us to identify the row in a tuple in a unique way. So in student table, we can say that SSN can act as a key. And the key can be a single attribute and it can be a composite. For some cases, it can be composite. Sometimes row IDs or sequential numbers are assigned as keys to identify the rows in table. So coming to the formal definitions associated with your relational model. Okay. So the first term is schema. So what is schema of a relation? Schema represents a relation itself. Okay. So schema is denoted by R of A1, A2 up to AN, whereas R is the name of the relation, whereas A1, A2 up to AN reflects the attributes of the relation. So schema refers a relation. Okay, a relation has a name and set of attributes. For example, consider a customer. Okay, so customer is the relation name. Okay, and the customer is known with his attributes like customer ID, name, address, and phone number. So here, customer ID, name, address, and phone number are the attributes belongs to the relation customer. And each attribute has a domain. Okay, has a domain in the sense a set of valid values it can assign. Okay, so the customer ID must be an integer. Okay, and it has to start with this number, and it has a role like this. And the customer name must be not null. Okay, and it must be a string. Okay, so like that, domain represents the set of valid values which can be used with the your attributes. So next comes tuple, tuple or tuple. So tuple is an order set of values, so which are enclosed within angle brackets. So order set of values. Each value is derived from an appropriate domain. Okay, domain in the sense set of valid values. So a row in the customer relation is a four tuple and would consist of four values. So for example, here the customer ID. So customer ID, name, address, and the phone number. Okay, so this is called a four tuple as it has four values. Tuple means a row in the customer relation. A relation is considered as collection of such tuples. Okay, so a collection of tuples formulates a relation. So next two tuples, the next term is domain. So domain in the sense set of valid values which can be assigned for your attributes. Okay, so here for example, in a customer relation we have attributes like customer ID, name, address, and phone number. Okay, so in USA phone numbers are set of 10-digit phone numbers. Okay, so the phone numbers must be 10 digits. 11, 12 digits should not be allowed. Okay, so a domain also has a data type or format defined for it. Okay, so the USA phone numbers may have a format that, okay, so here we have to provide the extension or the country code. Okay, so followed by, so first 3 digits, then hyphen, the remaining 4 digits. So this is the format they are being used. Okay, so the number of digits must be 10 and it has some defined format also. So likewise, to represent dates, we have a formats like we'll be using different format. So one of such format is year followed by month and date. So this is one format. Or else we can use DD space a month followed by the 4 digit of year. Okay, so we have to specify the format it has to be specified with. Okay, so the domain allows the domain specifies the validity of the values to be used as the value for your attributes. The attribute name designates the role played by a domain in a relation. Okay, so it is used to interpret the meaning of data elements corresponding to that attribute. Next is state. So what is state? The relation state is a subset of a Cartesian product of the domains of its attributes. So each domain contains a set of all possible values that attribute can take. For example, so the attribute customer name is defined over the domain of character strings of maximum length 25. Okay, what does that mean? So you can allow some 25 up to 25 characters you can allow as a customer name. Okay, the customer name cannot exceed the length of 25. So the maximum string length is 25. And name must be a string. Name cannot be a integer or date. So the value of customer name must be a collection of maximum of 25 characters. So likewise, we can define a domain value for the customer. So here, the domain of customer name is varchar of 25. So let me have a summary about the facts of relational model. So, what is a schema? Schema refers a relation which are specified with, which are identified with the relevant attributes, isn't it? So relation reflects any real world entity in any real world entity like student, customer, okay, and the entity has some associated attributes. Okay, so here your relation are identified with some collective attributes. So a name followed by a set of attributes constitutes a schema. So in the schema definition, R represents the name of the relation, and the set of values like A1 to AN shares R provides attributes of the provides information about attributes of the relation. Whereas R of R specifies the specific state. Okay, R, the value R, the population of relation R. So this is a set of tuple. So R of R equal to, so a subset of, that is a set of tuple constitutes a state. So the values populated, that is populated at a timestamp, matched with timestamp constitutes a state of relation. So here consider, assume R of A1, A2 be a relation schema, and let domain of A1 equal to 0 and I. Okay, so whereas domain of A2 can allow values from A to C, A, B, C. Then domain of A, that is the Cartesian product. Okay, so which gives all possible combinations. Okay, reflects the state. Okay, So a relation state can be a subset of the Cartesian product happens between domain of A1 and domain of A2. So for example, we can say that 0, A, 0, B and 0, C can be a state of a relation. So one possible state. Okay. And we can say 0, that is 1, A, 1, B, 1, C as another possible state. Population or extension of a relation R defined over A1 and A2 constitutes a possible state. Okay. So informally, suppose we are informally, table represents a formal term relation. Okay. So and column header corresponds to attribute, and all possible column values are referred as domain as formally. Okay. And each row of your table formally known as tuple. Okay. And the table definition formally called as schema of relation, whereas the populated table formally addressed as state of the relation. Okay. Again, I'm repeating. Informally, suppose we are calling as table means which is formally we can address that as a relation. Okay. And each column header represents attribute of a relation, and all possible column values represents a domain. Okay. Domain in relational model. And each row of a table corresponds to tuple. And your table definition refers schema of relation. And your populated table, okay, at each time specifies the state of the relation. So here, consider this table. That is, so this is a table. Okay, so the table is for students. So we can say this reflects a relation student. Okay, student, and it has attributes like name, SSN, home phone number, address, office phone number, age, and GPA. So these are the column header corresponds to attributes, and student refers the relation name, and each record, okay, facilitates each record of a particular entity. Okay, like Benjamin Weyer, Dick Davidson. Okay, so these are, so each row is considered about consider as information about a single entity. Okay, single entity realized in your practical life. So each row constitutes a record of a single entity. Row are that is row informations of the particular table are formally called as tuples. So in this corresponding state, okay, so what is the state of the relation? So for this particular timestamp, the student relation has 5 records. Okay, has 5 records. Later on, it can be populated with some 7 records, 10 records. It can hold as many records as possible. But in this particular timestamp, the state of the particular relation provided with 5 tuples, or we can say it is populated with 5 tuples. So the facts about relational model. Okay, the important terms about relational model are discussed. So we have discussed what is schema, what is tuple, and what is column header, and what is state. Okay. Informally, how we are calling, and formally, how we are representing. Next, I would like to introduce the characteristics of relations. Okay. So, first comes the ordering of tuples. Okay. So, the tuples are not considered to be ordered, even though they appear to be in a tabular form. So, it is that is we can say that the tuples cannot be in a ordered way. Okay. So, we can store the attributes of the particular entity in any order. Okay. Then ordering of attributes in a relation schema. Okay, so here we will consider the attributes. Okay, so we have attributes like A1, A2 up to AN. So whereas the values, okay, assigned to that attributes must be in order. Okay, so the tuples need not to be maintained in order. So whereas we have to pass the values to the tuples, okay, in the order your attributes are defined. Okay, so we should not change the order of attributes, okay, while passing the value to the tuple. So we have to maintain the order of attributes in your relational schema. So whereas order of tuple, that is tuples, need not to be maintained. So for this student relation, suppose I want to feed new information about the entity whose name is some Robert Clue. So I want to add the information about the student Robert Clue. Okay. So to insert values about Robert Clue, I have to pass the values in the order: name, social security number, home phone, address, office phone number, age, and GPA. I have to follow the order of attributes which is defined in your relation. Okay, I have to follow the order of attributes. Okay, so whereas I can insert the information of Robert Clow at first. Okay, so I can insert anywhere. Okay, I can insert the particular information about, that is the information of Robert Clow at any place. Okay, he can be inserted as the first record, or somewhere at fourth record, or somewhere at last. Okay, so the order of tuples need not to be maintained, whereas the order of attributes has to be maintained. So next comes values of the tuple. Okay, so all values, okay, which are assigned to be a part of a tuple must be atomic. Atomic in the sense indivisible. Each value in a tuple must be from the domain of the attributes for that particular column. Okay, so consider we have a tuple T, okay, which has a value set from V1, V2 to Vn. Okay, so T is equal to V1, V2, Vn is considered as a tuple in the relation state or of the relation schema R, which has attributes defined from A1 to An. Okay, then each Vi must be value from domain of Ai. So the value must be have match with the domain, that is the domain specified for the particular attribute. Okay, so the value of the tuple must match with the domain set of the particular attributes. So when suppose so in case you are not knowing a value for the particular attribute, means you can use the special indicator, that is special value. null. Special value as null for certain tuples. So the component values of a tuple T can be represented or denoted as T of AI or T dot AI. Okay. Similarly, T of AU to AW refers to the subtuple of T containing the values of attributes AU, AV, AW respectively in the tuple T. So the formal definitions and characterization of relations we have discussed so far. Now we are going to introduce the constraints. Okay, so we start integrity constraints. So what is a constraint? Constraints are conditions that must hold on all valid relation states. So constraints means conditions. Okay, so in a relational model, we are having three main types of constraints. Okay, and those are key constraints, entity integrity constraints, referential integrity constraints. So these are the three main types of constraints. And another implicit constraint is the domain constraint. Okay, so we know what is a domain it is. So what is a domain? So domain represents a set of possible values, okay, which can be allowed for a particular attribute. Okay, so every value in a tuple must be from the domain of its attribute. Okay, it can be a data type, and data type can also be provided with a format also. So in simple term, we can say constraints are conditions a particular thing must adhere with or hold. So there are three main classes of constraints: key, entity, integrity, and referential integrity. So let me start with key constraints. So to proceed with key constraint, we must know the details about what is a super key and what is a key. Okay, so we know what is a key. So key is an attribute, or it can be a set of attribute which allows us to retrieve a record from your relation. Okay, in a unique way. Okay, that is a key. So whereas super key, so super key of relation R is defined as, so it is set of attributes. Okay, SK represents a set of attributes of R. Okay, which match the following condition. Okay, so the conditions are no two tuples in any valid relation state R of R will have the same value for SK. Okay, which means for that particular attribute, okay, or a set of attributes, there shouldn't be any same values found in more than one tuples. Okay, so each attribute must have a unique value. Okay, each must specify or facilitated with a unique value. Okay, so if it is provided with a unique value only, we can retrieve your rows or tuples in a unique way, isn't it? So no two tuples, okay, for in any valid relation state R of R will have the same value for SK. Okay, so that is the first condition. The second condition, that is for any distinct tuples T1 and T2 in a state R of R, T1 of SK should not be equivalent to T2 of SK. Okay, so these are the two conditions. That is, your tuples T1 and T2 have distinct. Okay, so these two are considered as different tuples. That is rows. So in a particular state, okay, in a particular state, the values in, that is the attribute values of T1 should not be matched with attribute values of T2. Okay. So these are the two conditions. So it can be a single attribute or a set of attribute which are identified as a super key should not have a common value. Okay, should not have a common value. That is the constraint. That is the condition. So to bring a particular attribute as a super key, or to nominate any particular attributes or set of attributes as a super key, okay, it must hold the conditions that not two tuples in valid relation state R of R will have the same value for the SK, that is the set of attributes, okay, which are defined with SK. Okay, and for distinct tuples T1 and T2, okay, so which is found in the particular state of relation R of R, okay, so the T1 of SK, that is the values inferred in T1, okay, for that particular set of attributes which are nominated as SK should not be equivalent with the value, that is the value provided in T2, okay, for the set of attributes which are nominated as super key or SK. Okay. And what is the key? So super key constitutes a set of attributes. Okay. So as key, a minimal super key is called as a key. Okay. So that is a key is a super key such that removal of any attribute from K results in a set of attribute that is not a super key, does not possess the super key, unique. Okay. So we can say that a minimal super key is considered as a key. So we will discuss with an example. So consider a car relation schema. Here comes. So the relation name is car and it has attributes state, register number, serial number, make, model, and year. Okay. And car has two keys. For example, so here state and register number, okay, are used. Okay, so together these two attributes are used, are nominated as key one. Okay, so and serial number, okay, again nominated as key two. Okay, both are also super keys of car. So here serial number and make is a super key. So we can say serial number, the combination of serial number and make is a super key. But it is not considered as a key. So to retrieve the tuples uniquely, we can use register number and state as key. Okay, or we can use the serial number alone to uniquely identify each and every tuples. Okay, so we can use either serial number, okay, a single attribute as a key attribute, or we can make use of state and register number. Okay, so to uniquely identify or retrieve a tuple from your relation car. Okay, so these are the two keys. Okay, so these two keys, we can nominate these two keys as a super key. Okay, we can say these two keys are as super key. And apart from these two keys, we can formulate a new key. So with serial number and make now. Okay, make. Okay, this composite attribute can also use to retrieve the tuples of a car relation uniquely. Okay, so it can be considered as a super key, but we cannot nominate this as a key because the make, there can be some duplication for make, isn't it? So the cars can be made with the same materials for multiple tuples, that is, for multiple tuples, make can have a same value. Okay, so we cannot allow the serial number and make as the combination of these two as a key. Okay, so in general, any key can be nominated as a super key, but a super key cannot be used as all the time. A super key will not constitute a key. Okay, so that is the fact. Any set of attributes that includes a key is a super key. Okay, whereas a minimal super key is called as a key. So we can use serial number as a key, but we cannot use serial number and make as a key. So that is the information we have info from this slide. Okay, and there is one more term, that is candidate key. So if a relation has several candidate keys, one is chosen arbitrarily to the primary key. So for example, so we are here, the for car relation, so we are having multiple super keys, right? So multiple key candidates. Okay, so what are they? So we can use state and register number as key, or alone we can use the serial number as a super key. Okay, so so we have multiple candidate keys. So in the multiple candidate keys, we can nominate one as the primary key. Okay, so the primary key attributes are specified with underline. Okay, so to make a representation, that is to make a clarity that so this particular attribute can be used as a primary key. So the primary key attribute must be specified with underline. Okay, so in a relation, suppose we are having any attribute specified with underline means, so that attribute we have to that attribute with underline says that is the primary key attribute. So we have chosen serial number as the primary key. So the primary key value is used to uniquely identify each tuple in a relation. Okay. So the smallest of the candidate key always be chosen as the primary key. And the primary key can also use to reference a tuple from another tuple. Okay. For example, okay. So here, consider another relation schema which is on car, but here we have attributes: license number, engine serial number, make, model, and year. Okay. So here, so we can use either license number as a key or engine serial number as a key. Okay. So we have two candidates for keys. So among the two candidates, we have elected the license number as the primary key. Okay, so that's why it is provided with underline. So there must be a license number for each car. But for some entries, okay, so for engine serial number, so uh, may not be known. It can be null also in sometimes. So uh, engine serial number is not elected as the primary key. So we have chosen license number as the primary key here. So once again, the schema of relational database is provided here. A set, yes, of relation schema that belong to the same database is considered as a schema. So S is the name of whole database schema. So S equal to R1, R2 up to Rn. So whereas R1, R2 are name of individual relation schemas within the database S. Okay. So a set of relational schema constitutes a database. Okay. So for example, a company database. Okay. Company database includes the relations like employee, department locations, project, works on. Okay. So these are the various relation schema which constitutes a database company. Okay. So a database. Okay, database are nothing but collection of tables. Okay, so informally we can say a collection of tables constitutes a database. So key constraint we have discussed. Under key constraint, we have defined a super key, and from super key, there may be multiple combinations of key which helps us to retrieve a record uniquely from your table. Okay, so there can be more than one there can be more than one choice of having a key attributes. So among the various choices, we have arbitrary. We have to select one particular key as a primary key. Okay, and what are the conditions it has to satisfy? Okay, the condition is the general condition is no two tuples must have the same value. Okay, for the elected attributes which are nominated as key. Okay, so that is the basic constraint it has to meet with. So key constraint we have done. Moving on to entity integrity. Okay, so what is entity integrity? So the primary key attributes PK of each relation schema or in S cannot have null values in any tuple of R of R. Okay. So entity integrity in the sense the attributes which are nominated as primary key should not have null values. Okay, in its value. Okay, at any point of time. That is entity integrity. Okay, so this is because primary key values are used to identify the individual tuples. So T of Pk should not be null for any tuple T in R of R at any state. R of R means state. At any state, your value of Pk should not be null. Okay, so if Pk has several attributes, null is not allowed in any of these attributes. Okay, so the key, okay, that is the attribute, what you are nominated as key should not hold a null value. Okay, it must disallow the null values. Okay, that is entity integrity constraint. Okay, so key constraint we have done, and entity integrity constraint in the sense. So what attribute we have nominated as primary key that should not have a null value in it. That is the constraint. Next, moving on to referential integrity. So referential integrity involves two relations. That is, this is a constraint which involves two relations. So um, That is, the previous constraints involve a single relation. Okay, so here referential integrity involves two relations. Okay, it is used to specify relationship among tuples in two relations, two different relations. Okay, so one relation is named as referencing relation and another relation is named as referenced relation. So tuples in the referencing relation R1 have attributes Fk. Okay, means foreign key. Fk means foreign key. Foreign key. That reference the primary key attributes Pk of the reference relation R2. So which means suppose we are having two different relations named R1 and R2. Okay, primary key. Okay, which is specified in R2. Okay, has its place in as attribute in R1. Okay, means R1 is called as referencing relation, whereas R2 is called as referenced relation. Okay, PK, that is attribute which is nominated or which is used as a primary key in one particular relation. We are using the same attribute in some other relation as one of the attributes. Okay, so in that case, that particular attribute can be called as a foreign key. Okay, because we are referencing the primary key, okay, of the relation R2 in R1. Okay, so in R1, it is called as foreign key. Okay, so consider a tuple T1 in R1 is said to be reference a tuple T2 in R2 if T1 of Fk equal to T2 of Pk. Okay, so referential integrity constraint can be displayed in a relational database and as a directed arc from R1.Fk to R2.Pk. Okay, it is derived. So in simple term, how we can say now, suppose I'm having a relation R1 and R2. Okay, and I have nominated some attribute as some that is okay, in R2 I'm having a attribute which is nominated as a primary key. So whereas I'm referencing the same primary key attribute in relation R1 means I can say that particular attribute as a foreign key. Okay, I will. So later I will give you an example. First, we will conclude the constraint, that is the condition for referential integrity. So the statement of the constraint comes here. The value in foreign key column, okay, F key, of the referencing relation R1 can be either the value of an existing primary key value of a corresponding primary key Pk in the referenced relation, or it can be null. Okay, so this is the condition it has to meet with. So in case 2, okay, that is Fk in R1 should not be a part of its own primary key. Okay, so it can allow null value. Okay, if the R1 should not be a part of its own primary key. Okay, so suppose the particular, so we are not making use of that foreign key as a primary key for your relation R1 means we can allow null value. So that is your case 2. So you can display your relational database schema, okay, as row of attribute names. The name of the relation is written above the attribute names. The primary key attribute will be underlined. The foreign key constraint is displayed as a directed arc from the foreign key attributes to the referenced table. Okay, you can also point the primary key of the reference relation for clarity. Okay, so for example, for the company relation, okay, so we are having a depiction here. So we have so many relations, okay, that is for company database, we have relations like employee, department, department locations, project, works on. Okay, and the pending. Okay, so here, so in employee relation has attributes like F name, middle name, last name, social security number, birth date, address, sex, salary, and uh, super SSN and D number. Okay, D number refers department number. Okay, and we have we have department. In department relation, we have D name, department name, number, manager SSN, and manager start date. Okay, so here, so in employee, we have so many attributes. Among all other attributes, SSN. Okay, so we can use SSN to uniquely identify each tuple in your relation, that is employee relation. So SSN is declared as a primary key as it is provided with underline. So here SSN is declared as a primary key. Okay, and we have a department. So in the department, we have attributes like D name, D number, manager SSN, and manager start date. So among these attributes, D number is elected as primary key. Why? Because D number has will allow unique value. Okay, so that for that reason only we have nominated D number as the foreign primary key for the relation department. Okay, so whereas the department number is referred. Okay, it is referred in your employee relation to. Okay, employee relation to make a interrelationship between that is to plot or to infer the relationship between employee and department. The department number is used as one of the attribute in employee. Okay, so here department number, whereas the department number is primary key attribute of department. So in employee relation, it references, okay, department number from the referencing relation department. So department is considered as the referenced relation. Employee is considered as the referencing relation. Okay, so here the primary key D number in department, okay, is called as foreign key as your employee relation. Okay, so here it is foreign key, whereas here it is primary key. So a primary key of one particular relation used as one of the attribute in some other relation is simply called as a foreign key. Okay, so the base relation which has the primary key is known as referenced relation. Okay, so a relation which is making use of that primary key attribute, okay, in its current relation, so which is called as a referencing relation. Okay. As D number is not a key attribute, primary key of your employee, so D number can refer any value from your department. Okay, means that D number can hold any tuple value of department, or it can be null also, as it is not part of a primary key. So the three main classes of constraints we have discussed: key, entity integrity, and your referential integrity. Then, okay. So there exists some other types of constraints, so which has less focus. Okay, and those are semantic integrity constraints. So based on the application semantics and cannot be expressed by the model per se. For example, max number of hours per employee for all projects he or she works on is 56 hours per week. Okay, so a constraint specification language we have to be used to express these in SQL 99. Okay, and it can be used, and it allows triggers and assertions to express So you can allow or specify the semantic integrity constraints. So you can formulate a semantic and you can eliminate or you can restrict the values, okay, by specifying the semantic constraint. So each relation will have many tuples in its current relation state, okay. So the relational database is a union of all the individual relation states. So whenever the database is changed, a new state arises. Okay. So the basic operations which changes the database state are insert, delete, a modification. Okay. Means that these operations constitutes the different states for the relation. So for this particular timestamp, we have some 8 tuples. Okay, 8 tuples in employee and 3 tuples in department and some 5 tuples in department locations and so on. Okay, so in later on, okay, probably we can insert a new tuple in employee, or we can delete some tuple from employee, or we can update some value in the employee, isn't it? So these basic operations are basic operations like insertion, deletion, and updation makes that facilitates changes in your database. Okay, and so these are the basic operations. These operations changes your database state. Okay. While applying these operations, the integrity constraints what you have proposed over the relation should not be violated. So you have to maintain the constraints while performing the operations like insertion, deletion, and update. So in case of integrity violation, so you have to apply the following actions. Okay. So you have to cancel the operation that causes the violation, perform the operation but inform the user about the violation. Okay. Or you can use trigger. Okay. You can trigger additional updates so the violation is corrected. So execute user specific error correction routine. Okay. So in to avoid a particular integrity violation, what we can do now, we can simply reject the operation, or we can apply the violation with prior information to the user, or we can use some trigger events, or we can formulate some triggering mechanism. Okay. So to update or to correct the violations, or we can propose error execution routine. Okay, when a violation, integrity violation is encountered. So these are the various ways we can handle the violations of operations. Okay, so the insert operation may violate the constraints. Okay, domain constraint. Okay, so if one of the attribute values provided for the new tuple is not of the specified attribute domain, okay, then it constitutes a violation. Okay, so according to key constraint, if the value of a key attribute in the new tuple, okay, already exists in another tuple, okay, in the relation means that constitutes a key relation, that is key constraint, that constitutes a violation of key constraint. Okay, then according to referential integrity, consider you're having a foreign key value. So if your foreign key value in the new tuple references a primary key value that does not exist in your reference relation, then it leads to a violation, isn't it? So, and with respect to entity integrity, the primary key value is null. Okay, so in the new tuple, then it leads to a violation. So these are the possible choices of violation with respect to insert operation. Okay, and with respect to the, okay, these are the possible cases when a delete operation may violate your integrity constraint. Okay, the first one is if the primary key value of the tuple being deleted is referenced from other tuples in the database. Okay, so in that case, it leads to a violation. Okay, so to resolve this, you can restrict or you can use cascade or set null. Okay, keywords. So in restrict, you can reject the deletion. In cascade, you can propagate the new primary key value into the foreign keys of the referencing tuples. In set, by using set null option, you can set the foreign keys of referencing relations to referencing tuples to null. Okay. So like this, you can resolve the violations. Okay. So here comes how your update may violate the domain constraint. Okay. Any of the other constraint may also be depending on the attribute being updated. So while updating the primary key, okay, so similar to a delete followed by an insert. So need to specify the similar options to delete. Okay, while updating a foreign key may violate your referential integrity. Okay, and updating an ordinary attribute. Okay, that can also leads to a violation of domain constraint. So in this session, we have summarized the definitions of relational model concepts, followed by the characteristics of relations. Okay, and we have discussed the three main classes. Okay, of integrity, that is constraints, key entity integrity, referential integrity, and we have discussed domain constraints. So we have discussed four classes of integrity constraints. And what are the possible operations which may violate the constraints and how to resolve the constraints. So we have discussed all these things. Okay. So a small exercise. So consider the following relations for a database that keeps track of student enrollment in courses and the books adopted for each course. Okay, so in this relational schema, we have relations like student, course, enroll, book, and text. So you are asked to draw a relational schema diagram specifying the foreign keys for the schema. Okay, so have a look into each relation. So here SSN is underlined. So SSN is a primary key of student. Okay, and in student we have SSN, name, major, and B date. Okay, and so there is no primary key. So it is not referencing any primary key attribute of other relation. So it is done. Okay, then coming to course. In course, we have three attributes: course number, CNAME, and department. Okay, and among these three, course number is specified as primary key. Okay, so here there is no place for any other primary key attribute referenced here. So here it is fine. So there is no place for foreign key here. Okay, then coming to enroll. Okay, here we are having SSN. So which is a primary key of student. So here SSN is foreign key. Okay, so which is referenced from the relation student. So SSN is foreign key and course number. So course number is also a foreign key. Okay, so course number is referenced from the relation course. Okay, which is a primary key of course. Okay, so here SSN is a foreign key which is referenced from the relation student, and course number is a foreign key which is referenced from the relation course. Okay, and coming to here, okay, book adoption. Course number is a foreign key, okay, which is referenced from the relation course, whereas quarter is a foreign key which is referenced from the relation enroll. Okay, then coming to text, book ISBN number is a primary key attribute here, So whereas this is not original, okay, here it is primary key. In text, it is primary key, whereas in book adoption, the same attribute is referenced here. So book ISBN number is a foreign key, okay, which is referenced from text. Okay, so book ISBN number is a foreign key considering your relation book adoption because it is referenced from the relation text. So by this session, we have elaborately discussed the relational model concepts and the integrity constraints. Thank you, students, for your patience hearing. Thank you all.